All right, on this video, I want to talk about utilizing the delta operation in monadic theory, and more specifically, its use on polynodes. Um, I believe I didn't address that last time, so I kind of want to show an idea of where I've been going with on this, and I'll show you on the board what I mean by all that. So um, we'll call it first off. So deactivating a polynode. So a polynode essentially is any node has more than one of itself with zero additivity. And I've been kind of using the parentheses to kind of show another form as the graph. Actually, we don't need that. We just need that. Showing that there's two of those. So that was the whole idea of binode, right? Then there's trinode, whatever. You get an nth node. So that was the whole idea behind that. So a delta operator on that would be something like, so now you kind of got the idea. I'm just going to erase this graph part. Now, if you take and deactivate it, it's already kind of got the parentheses. So, and we'll just show right below what we're showing there. So when you deactivate a polynode, what you're left with, it loses a copy. It loses a copy of itself. So then you're just left with the node by itself. So to show the graph part, so I do this, and then we're going to just put like we'll just do this number and just put a delta there so you know, and then why not an arrow there that just shows that something along the lines of that. It says one of these disappear. It doesn't specify which one. I don't have anything that like specifies order in that. It just says one of them disappears. And since they're essentially identical, it doesn't really matter in this context which one disappears. So, and let me show it with more than two. Say we have a chain of these, and we're just going to see, well, we'll just put there. So, blah, blah, blah. All right. So, say we got four of them, right? Well, delta. And then it just leaves three. And then from here, you can see how eventually you get down to something where you get to a delta. If you were to keep doing the same operation over, when you're using a delta on that, and as I showed before, when you use the delta on your single a node with no additivity, it basically gives you this. It completely deactivates it into the Mu universe. And some interesting features about this is the fact that it goes into this. So there's not really a concept of a universal or a null in the Mu universe. It's just all Mu, because everything is essentially there. It's just deactivated. Anything could be in there, but it's just deactivated. So it doesn't really matter what it goes back into because it just deactivates. It's just like, well, it's done with it. You can always bring it back up, you know, by using using the alpha. Or sorry, oops. Yeah. Use the alpha on this, and then it gives you that back, right? So you can always bring it back, but this just basically says we're deactivating it, and it's kind of absorbs it. I kind of like been using that term. It absorbs it back into the Moo universe. So that's the whole idea of deactivating a polynode. Um, so I just kind of wanted to show that. All right. Thank you.